We can draw these conic sections, also called conics, on a rectangular coordinate plane as what we have done earlier, and find their equations. To be able to do this, we will present equivalent definition of these conic sections in subsequent sections and use this to find the equations. There are other ways for a plane and the cones to intersect to form what are referred to as the degenerate conics. A point, one line, and two lines. Please see figures 1.4, 1.5, and 1.6 on your module on page 9. The graph of the second degree equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0 is determined by the values of b squared minus 4ac, or also known as the discriminant. We have here the table 1 that represents or shows as the graph of a quadratic equation. So, without graphing such equations, we can easily determine if what thus the graph will look like by just using this b squared minus 4ac. So we can say that the graph will be a circle if the value of b squared minus 4ac will be less than 0, or a is equal to c. Next, it will be a parabola if b squared minus 4ac is equal to 0. Ellipse if b squared minus 4ac is less than 0, b is not equal to 0, or a is not equal to c. Hyperbola if b squared minus 4ac is greater than 0. So let's write that legend here so that we will have our guide in our solvings later on. So b squared minus 4ac is less than 0, or a is equal to c. It will be a parabola if b squared minus 4ac is equal to 0. Ellipse if b squared minus 4ac is less than 0, b is not equal to 0, or a is not equal to c. And lastly, we can say that it is a hyperbola if b squared minus 4ac is greater than 0. So we will use this legend later on in our example to determine what is or what thus the graph will look like by just having that equation.